Hi, I'm just going to make a quick video to go over questions 35 and 43 from the 5-5 homework, looking at odd and even functions. So when you're trying to determine if a function is odd or even, when you have the equation, you need to first of all figure out what is the value of the function, or what is the function going to be equal to if I put in a negative x into the function instead of an x. So I'm going to take my original function exactly as it is, but I'm going to replace the x with a negative x. And then I'm going to simplify that. And if I've got a negative x and I'm squaring it, when I square a negative, it's going to become positive. So it's going to give me negative, and then that's just going to become an x squared. I'm going to bring down my minus 5. And as I look at that, you'll notice that it is exactly the same as the function that I started with. So therefore, it's equal to g of x. And from our definition of odd and even functions, we know that if g of negative x equals g of x, that tells us that the function is even. If we look at this and graphically, this is the function graphed here, and you can see that it's just a parabola. It's upside down, it's shifted down 5 units, and you can see that it is symmetric across the y-axis. Let's take a look at the next one. If we do the same thing, I'm going to now take this function and I'm going to substitute, instead of x, I'm going to put in a negative x. So everywhere where there's an x, I'm just replacing that with a negative x. Now I'm going to try and simplify that. So I have a negative here. I'm going to take my negative x raised to the power of 3. Since it's an odd exponent, it's going to end up being negative. And so I'm going to have negative x cubed, and that can just leave it like that for now. And then here I have a 3, and I've got negative x. That negative x is squared, so that's going to become positive. So that would be x squared minus 9. Well, if you look at this part of it is exactly the same as that function, but we also have this negative in the front. So that's saying that this is equivalent to negative h of x. And from our definition of odd and even functions, we know that if h of negative x is equal to negative h of x, then that tells us that we have an odd function. If we look at this one graphically, this is what that function looks like. And you can see that this is symmetric around the origin. If we rotated this 180 degrees, it's going to lie on top of itself, or if we reflected over the x-axis and the y-axis, it would lie on top of itself. So again, we can see that this one's an odd function, this one's an even function. There's another option, which is neither. So if you do something like this and you realize that it doesn't equal g of x, it doesn't equal the negative of the original function, then that means it's neither of them. There are many functions that are neither even nor odd if neither of these two things are true.